Hey guys, my name's Eric Westfall. This is James. We're going to talk to you guys a little bit about Elsevier's work around productionizing Nomad for our container workload. It's going to be a demo-heavy talk, so we're going to blast through these slides really quick. So hopefully you don't get whiplash as we go through these. Like I said, my name's Eric Westfall. I'm principal engineer at Elsevier's Core Engineering team. This is sort of a slide that we always like to call ourselves like jobs and WAS, but everyone sort of calls us something else, so this is probably more accurate. So,
and my name's James, again, principal engineer, based in London. Eric's based in the US, so we pretty much have done all of this through conference calls, lots of conference calls. And so what do we do? What does Elsevier do? So Elsevier, primarily kind of a research company. We help researchers with a plethora of tools that we have. And in Elsevier, we've got many hundreds of complex web services, applications, distributed systems. We serve around 50 million users worldwide. And to do that, we have 7,000 employees, and that equates to there's 1,000 engineers spread across 12 countries, working in a variety of roles, QA, development, and more kind of systems engineering that we do. And we're part of the core engineering team. Our responsibility is to build reusable kind of frameworks and toolings that the entire enterprise can use. Such as repeatable kind of commodity, consumable stuff.
Just a quick little glance at some of our requirement gathering process. When we're doing these sort of like cluster scheduler decisions, we had to sort of weigh out all the different options between Kubernetes, Mesos, and Nomad. So before we do any large projects like this, we always gather requirements from our stakeholders, figure out what we're trying to achieve, and then we rack and stack the solutions to come up with a POC. And naturally, Nomad came out on top after we put them through a fairly rigorous set of requirements testing. I was a big fan of Kubernetes, so I was quite surprised that Nomad did as well as it did when it stacked up against the Elsevier requirements. So just talk about those a little bit. Like James mentioned, we have a bunch of different distributed teams. I think we said a little over 7,000 employees. There's about 1,000 technologists in Elsevier across a bunch of different countries. Some of them are siloed in like 40 different development teams. All of them sort of responsible for their own applications and services and their own deployment models and operations as well. So when we looked at this, we really had to say something had to be operationally simple and deployable by those teams independently within their own constructs. So we couldn't do like a massive PaaS layer solution. So that was really key and one of the big differentiators between Nomad and Kubernetes for us at the time. The other area wanted to fit into our existing platform and deployment methodologies, meaning Elsevier is very heavy on the Hashy stack before we picked Nomad, so we were using Terraform, Packer, and all those things. We wanted to make sure that what we deployed was automated and could be reusable. And so what we did was just sort of take the Terraform modular approach, Terraform modules we'll be demoing today, to do all this deployment. And the last thing was flexibility and customization. And this is where Nomad really shines for us. The APIs and the extensibility of Nomad are pretty much endless. If it doesn't do something, you can figure out a way to do it. And that was key for us. And hopefully we'll show you some of the things that we've done to extend Nomad to meet our requirements.
So what was the solution we come up with? So as Eric said, we went for Nomad. At this point, I am going to try and deploy the cluster. So we don't have a cluster running. I will try and prove that. And now I have to put mirroring on.
So yeah, while he's getting this sorted, what we're going to do is a deployment today of the cluster from scratch. And hopefully all of that stuff will be ran through Terraform. And generally, a cluster can go from nothing in AWS to a full production-ready cluster, automatically bootstrapped in about 4.5 minutes. So that's usually what we find.
So
you're not displaying.
Oh, for God's sake. Mirror displays.
There you go.
There we go.
There you go.
Perfect. Big enough? Just about. So I'm not lying. We don't have a cluster running. Our claim is that we can do a new cluster in 4 minutes. This includes a quorum of 3 nodes and 2 distinct worker pools. We don't really go into the distinction of worker pools during this, but we're happy to talk afterwards. Design that we kind of came up with recently, we think it works really well. So, as Eric said, we do everything in Terraform. Everything's a Terraform module. This is no different. It's actually going to be, well, we've got 3 modules. There are 2 modules imported 3 times. We have a module for the servers and then a module for the worker pool. So we're going to do 186 things, and let's hope this works. And that'll go away, and we'll just keep going through this. Okay, fine, that works. Just out of interest, who uses Mesos here? Surprised? Mesos was really disappointing to us. Really disappointing. I'm guessing most people Kubernetes? Nomad?
Wow.
More than I expected. Awesome. And so our solution, our kind of goal was to build a production-ready containerization platform that developers can pick up, they can run the Terraform modules with a little bit of Puppet code, and they just get a cluster. That was the aim goal. And so as I said, deployed in 4 minutes, cross fingers, minimal Puppet configuration at runtime, just to do some runtime kind of configuration. The majority of the time is Amazon boot up time. So we're waiting around 3 minutes for Amazon to boot our instances. That's the same on the auto-scaling, which we'll demo. This was actually a quote from one of our architects at work. He was fairly impressed. The cluster has kind of many features that we've added. We've got advanced health monitoring, auto-scaling, some pretty simple deployment pipeline examples for our development teams to use, 0 downtime rolling upgrades of all the cluster binaries. You can do it in a mutable way using an AMI and roll the AMI through the cluster. We also offer a way where teams can just kind of run a very steady update across the binaries, and we manage workload and make sure that there's still quorum. And full backup and restore DR strategy. We can't have a production system without that, so we had to include that. And highly resilient. Consul and Nomad take care of that pretty well by themselves. During negative testing, when we got our MVP up and running, it was very hard to break, and it was one of the good reasons why we picked it. And even with the stuff we have in place, if we only have it in a single region, we lose that entire region. The way we back up and the way we've kind of got everything in code, we can bring it up in a new region in a matter of minutes. Downtime's pretty easy to handle. But of course, Nomad isn't kind of the be-all and end-all. There's a lot of kind of subsidiary things. So Puppet, Amazon is our primary cloud provider, Terraform modules. We got some custom Go daemons that we'll demo. And Fabio, if no one uses that, no one knows it, Fabio is great. And it's our default that we use out the box. Doesn't mean that we can't swap that for traffic or Envoy if you want something slightly different.
All right, so now we're going to go check on the status of the cluster build. We're gonna, if any of you guys were in the earlier talk today about Nomad, we're going to demo some of the new 6 features that were highlighted as far as the ability to do canary deployments, rolling updates, blue-green, as well as a pretty heavy focus on something we're calling Replicator, which is a Go daemon that we've written and open sourced that provides cluster and job auto-scaling in a single daemon for Nomad. So we're going to cross our fingers and hope this all actually worked the way it should have. Just get out of presentation. Hit escape. There you go.
Sweet.
Okay.
Right.
Okay. So yeah, it looks like the Terraform run finished, and we will check and see if we have a Nomad leader. And we do. So yeah, James is just going to do a little bit of setup here. We're just going to tunnel in. All of this is running on Elsevier's private AWS VPC, so none of it's publicly accessible. So we'll set up a SSH tunnel to give ourselves access into the Nomad cluster itself.
Sweet. And so the first thing we're going to do, I'm just going to deploy Fabio. We want to come up with a way to auto-load jobs into Nomad. Mm-hmm. It's a bit annoying, so we're just going to deploy Fabio. We deploy Fabio as a system job, so it means that Nomad will manage running this job on every node in the cluster that meets the requirements. It's a really nice feature, especially when we scale out the cluster. We don't have to make sure that this job, we rerun the job and it puts on the new node in the cluster. Nomad will actually manage running that job in the cluster for us and on the new nodes. It's really nice. And so this should just fire away super quick.
And so as you can see, we use Jenkins to orchestrate all of the CI/CD pipeline for Nomad. Our developers are already used to using Jenkins, so something that we thought was pretty important not to sort of switch things out for them. So we abstract away all of the Nomad API stuff and sort of just give them the same workflow they're used to. It just happens to be a ton faster when they're using Jenkins. So.
Okay, let me do this.
Just SSH into the node.
Yeah.
Cool. So yeah, anybody else using Fabio today with Nomad as a routing layer? It's fantastic. Everybody seems to love it. So if you're not familiar with it, definitely check it out. Zero config routing is awesome. So so we can see that Fabio is successfully deployed on the cluster. Like we said, we run it as a system job. So we've got 4 nodes in 2 distinct worker pools, and Fabio is running on all 4 of them. So now we're going to move on from this and get a deployment of some applications. So throughout this thing, we're going to deploy something that we call CE app. So CE app's just a little Go web daemon that we've written, a web service that starts an HTTP server and sort of responds to a version endpoint and spits it out. So
why is my plan not working? Oh, for fuck's sake, I know why.
Sort out our...
When reverse search goes bad.
There you go.
Cool.
Okay. So yeah, so this app, the first thing we're going to do is a canary deployment. So if you guys aren't familiar, this stuff came out in Nomad 6. It's a fantastic way to sort of control your destiny when you're updating versions here and kind of handle deployment, decide if it was working well. Once you're comfortable with it, you can promote it. So we're just going to run a quick curl here. This is just going to hit that web service version endpoint. As you can see, we're spitting out version 100 over and over again. And then we'll take this deployment and bump it to 2. You should see 0 interruption to that. And it should be very seamless. And then you'll see, as you guys are probably familiar, and from the talk earlier about running at scale, you can kind of control these update stanzas, how many are allowed to happen at once, what the stagger interval is. And so this lets us really run it in a very production-safe way. So I'm just going to update this, and this should deploy the 200 canary. And as you can see, we've got 1 canary out there now. Hasn't touched the version 100 endpoints, but you'll probably start seeing a little bit of 2 flutter in there a little bit.
Yeah.
And this has all happened dynamically with Fabio, right? So Fabio's picked up this new canary. It will route a very small percentage of the traffic automatically to the canary, and we can watch that. Operators can look at the logs, make sure it's healthy, and then we'll promote it once we're ready.
Cool. Yeah, these are really nice features. When 6 came out, we were doing a lot of work with our internal development teams, and as soon as it came out, we were putting this into our demos, our internal demos, and it was a big feature that development teams kind of stood back and went, okay, that is really nice, that is really helpful.
So we're just going to do a manual promotion of this deployment, and this will take, and it'll follow the same rules, right? So whatever is in our update stanza, whether that be, whatever the stagger is and things like that will be observed, and Nomad will automatically deploy all the rest up to 2. So,
and we're not dropping any traffic, which is exactly what development teams want. And now I'm just going to purge this.
Shouldn't be doing this very often in production, but for the demo purposes, we're going to purge the job out of the history so we can do a blue-green deployment now. So.
Yep.
So this is going to be a traditional blue-green where we essentially manipulate the canary process, right? So if you have 3 running production hosts on version 1 and you want to do a traditional blue-green deployment, then you deploy 3 canaries so that it's even on both sides, right?
Our most common pattern is rolling deploy,
Yeah.
but having these available for maybe some of the more advanced development teams is really helpful.
It's highly dependent on how healthy or how robust a service's health checks are, really, more than anything. If you can trust that the application's testing is good and you can have confidence in the health check, rolling's where it's at. So, but a lot of teams really prefer controlling the.
And now we're going to go backwards from 2 to 1 because you do that a lot in production, particularly we do. And I forgot to change my atom setup. So if that deployment is finished, that's cool.
So again, same construct here though. So we're on a canary. We're going to manually deploy this. And the other thing that our teams have just been blown away with is the speed of Nomad, right? Like if you do this stuff on traditional EC2, a blue-green deployment might take you 15 or 20 minutes. Even in a normal, small, immutable ASG, it can be up to 5 to 10 minutes, right? And rolling back is terrible. In these scenarios, it's so fast that they don't really hesitate to do deployments now. So.
Yeah, and you'll see now in the core we've got the output of 2 and 1. Really nice.
Yeah.
Nothing's going wrong apart from my shoddy typing. But this one, we're just going to fail it. Let's say we found the problem. It's really nice to be able to do that.
Yeah. So again, we're going to pick this deployment, set it as failed. Again, this is going to mimic something we've went ahead and deployed this without testing properly, and now it's all gone south, and we're going to revert back to the previous version, which in this case will actually be 2.0.0. Opposite of what you'll ever do, but yeah.
And yeah, Nomad handles that perfectly. So stops our blue or our green deployment, increments the version onto the healthy, the stable version, and just leaves that in place. And we keep an eye on that. And one's dropped out, we're back to our original 2 version. And really nice. It gives us a lot of flexibility to just go to development teams. A lot of what we do is, as I said, this generic kind of setup, and with flexibility for developers to then kind of add and pick on what they choose, which helps them.
Okay, so we got about 20 minutes left. So the rest of this is going to focus on some of the scaling features of Replicator. So Replicator is a system daemon we've written in Go. It can run as a container in a Docker container job. It can run as an exec job directly on the Nomad host. Or if you want, it will run as a system binary as well on the server nodes or whatever you like. So, first thing we're going to do is deploy Replicator via the Jenkins CI pipeline. Again, this is one of those things where we're looking at is this whole auto load business, right? Which is there are certain things you always want running on a Nomad cluster when they come up. So it's something that we're looking at as well, is just figuring out a workflow that sort of gets all this stuff bootstrapped on a cluster from the beginning. So.
And we use this small helper script in this, so a small daemon. Just wraps does some templating and just wraps the deployment API with a watcher, so we can get a bit more feedback for developers in deployments. If you just use a Nomad binary, Nomad run, kind of runs it, and you don't really get much feedback on it. So this was something that has been pretty helpful.
And that'll be open source as well pretty soon.
It is already open source.
It is, yeah. Okay. So it's a project we're calling Levant, and that's on James's GitHub. But yeah, it's really nice to do sort of variable templating and monitor deployments as well. So.
Okay, so we've got Replicator running. I'm just going to grab it from here. And we can just have a look. So Replicator, you can run as many of it, but it does leader locking. So you can have 20 of them running. They do a spin lock, grab leadership, and then that one that's got leadership is the only one that's allowed to kind of do any enforcing. Yep. And the others will just sit there temporarily, keep trying to get the lock until, if they can, then they take over leadership.
Yeah. So we're going to deploy a copy of CE app. This time we're going to deploy a very large number of these just to try to force the worker pool that's running it to run out of space. And what we're going to do is watch Replicator do its job, which is to detect that this worker pool is out of space, and it's going to automatically increase the size of that worker pool dynamically based on the load that we're pushing onto the cluster, which is something at the moment that you can't do natively, which is sort of automatically respond to dynamic workload changes and meet that need. And the reason that we address this separately from sort of like, say, put it in an auto-scaling group and just scale on CPU or memory is how do you decide in advance what's safe and what your workload's going to dictate scaling, right? So we have a lot of different tunable algorithms inside Replicator that allow you to dynamically, it does all the work for you. So essentially you don't have to get in advance and say like, if the cluster hits 80% CPU, scale out or scale in. It figures it out based on whatever workload's present on there automatically. So as we push this job, it's going to strain the cluster, and Replicator should detect that and try to scale up. So as you can see, we've already placed 10 of these. This is a very small worker pool running on like T2 micros, so they don't have a lot of space. So just pushing 12 of these things should stress the cluster enough.
There we go.
Yeah, so here we can see that Replicator's automatically detected the worker pool requires a scaling operation. And in this case, it's saying that the direction is a scale out. It currently has 2 nodes. We can get into a lot of the details later, but the algorithm that it's using right now prioritizes the most constrained scaling metric on the worker pool and calculates capacity. It allows you to do things like, say, on a production worker pool, I should always be able to lose one of these nodes without having any impact to my workload. So it takes that into consideration when it's making these things, these decisions, as well as cluster scaling overhead for the job. So this is the one thing, several people have asked us why we do job scaling and cluster scaling in one project. And having them in the same project allows us to make a lot of decisions that we couldn't otherwise do. One of those is look for any job that Replicator sees that's scalable, that has a Replicator scaling policy on it, and consider that during the cluster scaling bit, right? Which is, okay, I might scale these jobs out by 1 based on workload, so I'll take that as a scaling overhead and reserve that threshold as well. So it gives you a lot of intelligence on what might happen in the future and allow you to consider that when you're doing scaling as well. So.
Well, the nodes kind of policy, so that's always running as a watcher. Mm-hmm. So, and so the job scaling policies, so they're running on watchers, and they always get the kind of the latest information when there's an update. It means that we're always kind of, if you deploy a few new jobs and they are all allowed to scale, the cluster scaling kind of part of Replicator is automatically and instantly aware of that. Mm-hmm. So we're always kind of balancing the cluster size. And it means in dev as well, if you want to run really lean in dev or staging, you can have your node fault tolerance at 0. Yeah. And it means you're just not going to have any fault tolerance, which is fine maybe in some environments.
This is a good point. As you can see in the output here, we have 2 worker pools running. Like we said, one's meant for private workload, one's for public workload. And they just have different security groups around them. But these are all running in multiple Go routines or threads, if you're not familiar with Go, sort of like threads. But it's all concurrent. So these are always running, and it's incredibly fast. Even here, where something might take a while because we're waiting on AWS to do work, what we're going to do here is increment the auto-scaling group, interact with the API to figure out what's the most recently launched instance, which we did, and then we'll use that polling mechanism to wait for that node to actually successfully join in the Nomad cluster itself. So all this stuff is going to happen automatically, and if it detects a failure during one of these, which it didn't in this case, it successfully joined the worker pool. If it hadn't, it would detect that and take the appropriate action. It would terminate that instance up to a maximum retry and keep retrying to scale that out for you automatically. If it hits that max retry, then it can save that node off to the side for you, let you debug it, and notify via whatever configured channels we support, things like PagerDuty and generic SNS and things like that. So we're going to add more support for all sorts of things like Datadog and things like that as well. So
yeah, we have a concept of fail-safe. Works for both the cluster and the job scaling. If we try and scale either the cluster or job, in this case the cluster, if we failed 3 times or whatever you've configured, it will put that worker pool in fail-safe. So Replicator will kind of ignore all the scaling that it wants to do for that. The idea being we don't want to keep trying to scale, keep bringing nodes in and out, and make that worker pool even worse than it already is. So the idea is we put it in fail-safe, and we alert out to an operator, and an operator actually has to remove that lock through a CLI command. So we have it, so it's supposed to look after the cluster as well as scale it.
Mm-hmm. So next thing we're going to do is show you job scaling, and we're going to use this as a 2-part thing. So this next copy of CE app will actually have a job scaling policy included in the Nomad job file. And what this is going to do is allow Replicator to, if you remember, we deployed 12 copies of this, and we certainly don't need 12 copies. It's not going to use it. It's going to scale it inward until it hits its minimum threshold, which we've defined. And then as a result of that, Replicator will automatically detect that we're way over allocated on that worker pool as well, and scale in the cluster as well. So again, this is exhibiting sort of one, the jobs can scale themselves based on load, which we're saying here. In this case, scale in if the memory is 30% or lower, CPU is 30% or lower, right, which it will be because we're not doing anything with it. So naturally, these jobs will scale into their minimum until replicator isn't allowed to go any further. All of these config parameters for cluster scaling as well as job scaling live right in the Nomad HCL file for the job. So they're all meta parameters. So you don't have to have like an external config or do anything weird like that. It lives with the job config as well. So we'll deploy this. And we'll watch replicator almost immediately start taking action against this. Now the job scaling is much quicker because Nomad's much quicker than AWS's API. So you'll see this almost immediately start cutting the CE app job count down by increments almost immediately. So as soon as this deployment finishes.
It'll take a few minutes. And like I was saying, the job policy watcher picks it up straight away. It manages the complete life cycle of job policies. So if you update one, it will pick it up. If you deploy a job, it will have a look at it, see if there's a change. If there is, update it. If you stop a job, cleans it up. If you remove a group from a job, we also do that. We do an orphan group check. We try not to, these are pretty fluid environments. We try not to leave anything left behind. The orphan pieces in our structures is less than ideal.
Yeah.
And so that will take a few minutes to deploy just because we're doing a staggered update on a job that's already running. But it should take about 10 more seconds, I think. And so what will happen, Replicator will start analyzing that job. It's within its configuration pool. And we will scale a job. At the moment, it's hard-coded to an increment or a decrement of 1. We're open to adding kind of configurable things. So it's kind of like Amazon auto-scaling. If I reach my CPU maximum, I want to add 2 because I want to be safe. At the moment, the scaling happens so quickly. We run it every 10 seconds. We run the daemon every 10 seconds. It happens so quickly, adding 1, taking 1 out, that's quick enough to handle any burst in load.
So as you can see, it's already taking scaling action on the CE app job, and it will continue to do so until it hits the minimum. And so we have this concept of safety gates that exists. So Replicator constantly, if it detects a scaling operation is needed, it'll keep trying, and if it's not allowed, the safety gates will block it, right? There's a billion different things that we do for safety checks. We can talk about that later if you guys are interested. But essentially, what you'll see is that this will just keep trying to initiate scaling operations until it's told it can't do it anymore. And in this case, the minimum threshold I think we set was 2. So once we're done here, we'll look at the Nomad status of the job, and it'll be 2 instead of 12. Yep. And at which point, the cluster scaling will detect that we're way over provisioned and take action. Now there's things like cooldown periods and all sorts of other things like that. So Replicator isn't allowed to sort of like just immediately start scaling the cluster if it's only been 2 minutes since we've done it. So, and you can, all that stuff's tunable, and you can, there's tickets that we have open to add other protections for like AWS instance launch time or AZ balancing and things like that as well. So, and while we're waiting for this to finish, we're getting ready to merge a PR that will make this a provider model. So all of the cloud provider specific stuff that works for cluster scaling will be done in a similar way to how Terraform's provider model works. So we'll be able to plug in things like Google Cloud, Azure, and things like that, as well as like maybe some more generic scaling things, like if you want to run Terraform instead of actually interact with the cloud API or something like that.
And whilst we're doing the scaling in the background, Consul health checks and Fabio are just doing their job. I can quickly jump onto the Fabio UI probably.
Yeah. So as each one of these decrements happen, we should see that Fabio automatically starts just dropping them off the route table almost instantaneously and reweighting the routes. So.
Yeah, Fabio is a brilliant piece of software.
It is.
Works so quickly out of the box. It's a bit boring to keep doing. And if I come out of that.
So I think our cooldown period for the demo is like maybe like, it's still probably 5 minutes, isn't it? So it won't be allowed to scale in any further than that. So.
Yeah, this will scale into 2.
Okay.
Eventually. And still, it's still trucking. If I scale that, if I screen up, we should hit, yeah. So when we're doing the previous deployments, we've not lost any traffic. Fabio console, everything we're doing It's keeping the cluster steady, stable. It's doing its job.
There you go.
And we're nearly there.
And the other thing that you notice probably why the original Jenkins deployment was running, it has one of its safety gates is if the job is in a deployment mode. And here you can see, so it's already reacted to the cluster over allocation. So now the direction is in instead of out. So we're going to scale down from 3 nodes in this worker pool to 2. And so when we're scaling in, there's some different decision logic that happens. So the provider, the cloud provider itself, will sort of work in tandem with the Nomad API to figure out what's the best node to terminate. So that logic is open to change here in the future. But at the moment, what we do is we take the least allocated node from the API's stance. So like I mentioned, the algorithm does a bunch of stuff, and we won't get into all the details, but it takes a prioritized scaling metric. What is the most constrained resource on the cluster? Is it CPU, disk, network IO, memory, whatever it is? Figures out which of those metrics is the most tightly constrained and uses that as the priority, and then looks at all the nodes that have workload on them and figures out which one is least allocated. That's the most eligible node for termination, and so that one floats to the top, and that's the one that we pick. We then put that node in drain mode and Nomad and wait for the allocations to move to other worker pools if they have any, and that'll pull and wait for that to finish. Once it has no active allocations, which in this case we see, the cloud provider will terminate that node by calling out to the scaling API, and in this case we'll confirm that the instance gets terminated successfully, which can take several minutes because the ASG API is a little bit slow to respond on occasions. So you'll see this do basically nothing while it sits here and waits for Amazon to actually respond to our request.
It's already done it, so it's already done it.
Oh wow, Amazon, nice job. It's a pleasant surprise. Usually this takes maybe 2 to 3 minutes for it to catch up and realize what we asked it to do. So, but yeah, so what I was saying earlier was that one of the safety gates for the job scaling perspective is that if, especially in Nomad 6 with the concept of deployments, if a job is in an active deployment mode, if, for example, you roll some canaries and you haven't promoted those, Replicator won't take any action on those, so it doesn't like pull the rug out from underneath you and start making changes while you're testing a deployment or something like that. So, so it's nice. And so as we can see, the watchers, which are running in the background, instantly pulling the Nomad API, see the change, and have now dropped the node discovery count to 2 for both worker pools. So we're back where we started again. So that demo took us from 2, put some workload, it scaled up automatically based on the workload, then we scaled the workload down dynamically, and then scaled the cluster back into where we were before we started the demo. So,
and now we're just going to do a rolling deploy of the scaling CE app to see the final few features of Nomad. So we're just going to do 2. This is going to be really quick because we've only got 2 instances of it running. So
this is the traditional deployment that you were probably already familiar with, but this is the sort of the rolling automatic deployment. And then after that, we'll look at the auto revert.
Yeah. This will take a few minutes. We've got things like, min healthy time, unhealthy time in there, stagger, auto revert. This should be fine. Version 2 does exist. And we'll see it's already done. The job's still running just because the deployment's not been marked as finished. It's still kind of running. It's still doing its final health checks. And there it just finishes.
Which I think is a good point. For production workload, it's really important to use some of those new features that are out there in the update clause, right? Is controlling your healthy limits and things like that are very important so that you can be confident. So what we're going to do now is deploy a version of this app that doesn't exist at all. So this should fail miserably, and auto revert is enabled. So this should try and fail and go back to 2 and not really take any outage at all. So
it's the most reliable way to break this. Obviously, if you in production, you'll deploy something and maybe it doesn't pass its healthy threshold because of an unknown reason. This version 3 just doesn't exist, so it should bomb out pretty quickly. There we go. And there we go, job failure. And if we just go back and look at the cluster, let's get rid of that.
And this is where job versioning really comes into play. So what you'll see here is that we actually did bump the version. Now we're on version 14 of this job when we started at 0. So that auto revert automatically bumped the version again for us. So yeah, and
you see that it failed because the allocation was unhealthy, rolled back to the previous known good state. And we shouldn't have lost any traffic. And we're still running version 2.
Yeah. So that's all we got for you, I think. We have open source replicator. Definitely open to some community feedback. We'd love to hear what you guys think about it. Going to try to endeavor to maybe work with some people and get some more support out there for different cloud providers and things like that, and definitely some other scaling backends as well. So,
yeah.
But yeah,
any feedback would be great.
thank you very much.
Been working on for a while, and yeah, thanks.